Uranium has a total of 92 protons, as you can see here, represented by the blue pins. Uranium's atomic number is also 92. What determines an element's atomic number is the number of protons it has. If you were to take away a proton, uranium would no longer be the same element. Uranium has 92 protons, as we've said already, but how do you find this on the periodic table? Well, on the periodic table, you can see uranium's atomic number right here, which is the same number of protons it has.
Uranium has 92 electrons, which you can count on this model, or see here. The electrons are very important because that is how the element bonds. It uses its valence electrons to bond. Uranium has 3 valence electrons, and the electrons are also the same number as the number of protons. Uranium has 92 electrons. How you can tell this on the periodic table is by its atomic number. Its atomic number is the number of protons an atom has, and that is the same as its electrons. So uranium has 92.
Uranium has 7 electron shells. Each ring represents an electron shell. Each shell also has its own designated number of electrons. The first holds 2, the second 8, the third 16, the fourth 32, and so on. Uranium has a certain number of electron shells. We can find these electron shells on the periodic table by looking at what row it is in. Each of the rows have a different number of electron shells. The first row has 1, the second row has 2, the third row has 3, and so on. Uranium, although it appears to be in the 9th row, is actually in the 7th row, because the actinide series are here, as represented by the AC, and the lanthanide series are here as represented by the LA.
Uranium is a metal, but how can you tell that on this model? Well, uranium has 3 valence electrons, and metals have between 1 and 3 valence electrons. The alkali metals on the periodic table have 1 valence electron. The alkaline earth metals have 2, and the transition metal family has 1 or 2, but uranium has 3. So it's part of the actinide series. You can tell uranium is a metal on the periodic table because it's colored differently. Metals on the periodic table are colored blue, while nonmetals are colored either orange or red. So you can tell uranium is a metal because it's colored blue.
All elements have multiple isotopes. This is one isotope of uranium titled uranium-235. It is titled uranium-235 because of the amount of neutrons in the nucleus. This specific isotope of uranium has 143 neutrons represented by the white pins. This is uranium's least stable isotope and is the one used to make nuclear bombs and reactors. It is called 235 mainly because the neutrons plus the protons equal 235. Uranium is a metal, but how do we tell what state uranium is at room temperature? You can tell that uranium is solid at room temperature because on this periodic table, solids at room temperature have no outline. If it were a liquid at room temperature, it would have a yellow outline, such as mercury. And if it was a gas at room temperature, it would have a green outline, such as hydrogen.
Elements bond using their valence electrons. I'm going to show you an ionic bond between uranium and nitrogen. An ionic bond is a bond between a nonmetal element and a metal element. Represented here by the 3 magnets are uranium's 3 valence electrons, and represented here by these 5 magnets are nitrogen's 5 valence electrons. The purpose of the bond is to fill the nonmetal's valence shell. A full shell of valence electrons will have 8 electrons. So, uranium will give its electrons to nitrogen, successfully filling its valence shell. This makes them both ions and gives uranium a charge of +3 as it has 3 more protons than electrons, and gives nitrogen a charge of -3 because it has 3 more electrons than protons. These opposite charges attract the two elements together to form the bond uranium nitride, which is written as UN with a U +3 and an N -3. The second type of bond that uranium can make is called a metallic bond. This occurs between metals of the same type of element. Here I have drawn a bunch of U's to represent uranium atoms. How they bond with each other is they send their electrons into a sea of electrons. This gives them all a positive charge of +3 because they have 3 more protons than electrons. The negative sea of electrons attracts these positive ions of uranium because it's the opposite charge. So they all bond to the sea of electrons. The difference between this and normal bonds is these electrons can move freely, which gives metals all its properties. It can bend, it can conduct heat and electricity because all these electrons can move freely. So electric current can flow through them, heat can flow through them, they can be bent into different shapes, and that is why metals have their properties. Uranium is a very useful element. As you probably know, it's used in atomic bombs. Uranium also has some other common uses. It's used to color glass because it gives it this awesome glow-in-the-dark neon effect and kind of looks like this. Uranium is also used in high-powered X-ray machines. It also is 70% denser than lead and sometimes is used in ammunition for the army as it creates a more dense, armor-piercing bullet. Does anyone have any questions?
Yes, Jordan, I have a few. Uranium is kind of a weird name. How did that happen?
Well, it's actually an interesting story. Uranus had 45 kids, so he was considered a baby-making factory, and uranium is enriched in a factory. Also, Uranus in Roman mythology is the god of the sky, and uranium means sky.
Hey Jordan, can you explain how uranium bombs work?
In a uranium bomb, a neutron is shot into the nucleus of a uranium-235 atom, because that is the isotope that produces energy. When it hits the nucleus, neutrons also shoot off and cause a chain reaction, making tons of energy and in turn the huge explosion.
Hey Jordan, isn't over 99% of uranium uranium-238?
Yeah?
But then how do uranium bombs have enough uranium-235 to function?
Well, they enrich it. How they do it is they take the uranium ore, which is over 99% uranium-238, and dissolve it in acid, turning it into a gas. They put this gas into a centrifuge, a machine that spins, creating a force thousands of times the force of gravity. Uranium-238, having more neutrons than uranium-235, is heavier, and so is pulled outwards towards the edge of the centrifuge. So the middle is slightly more concentrated with uranium-235. After doing this thousands of times, they can get the concentration of uranium-235 enough to make a uranium bomb. Hey Jude, how has uranium affected the world?
Well, you see, child, uranium has affected the world in many interesting ways. For instance, history was forever changed when the U.S. dropped the first atomic bomb on Hiroshima, Japan. Uranium is also incredibly widely used nowadays for power, for all of our electrical needs.